Hello guys, in this video we're gonna learn, this is unit 2 AP calculus multiple choice question response. In this video we're gonna learn everything about AP calculus and ACE 5 on this exam. So I pull up a question directly from College Board that deals with average rate of change. Rate of change, or known as a derivative, that is mostly in common with calculus work. So you're being asked, select the values of the function above. What is the average rate of change of f over the interval 1 through 5? So they're asking us average rate of change. When I remember average rate of change is like a derivative. It's kind of like a distance. What's the distance between one point to the other? And you gotta know the formula. The formula for average rate of change is f of b minus f of a over b minus a, meaning that endpoint minus beginning point over the speed at over the endpoint minus the beginning point. So it's kind of like distance over displacement, distance and velocity. It's kind of like almost it relates to the same concept. So we can say that x can be time, a t, and f of x, that is the y value, could be, for example, meters. It kind of goes back to the same constant of meters per second, and basically that is it. But we gotta focus more that the problem are giving us average rate of change. This is the formula. So basically what we have to do, what I have to do here is plug in the values that are given. Take note of interval from 1 to 5. I always like labeling point A from the beginning and point B. So I use the formula. So f of b is 14. 14 minus 2 over b minus a. The 2, if you're confused where I got the 2, f of a, that is 1. I got it from here. Over b minus a, that is 5 minus 1. We could do some simplifying. It'll work the same. But based on our answer choices, A cannot be it. B neither. C will be the final answer because I applied the average rate of change formula to determine that C is my final answer. And here, give me a moment. Okay, now we're gonna look at a justification, differentiability, and continuity. Okay, which of the following statements is true? Can be used to conclude that f2 exists. Okay, here let me draw a little graph here. So we want to prove that at this point f2 exists. They're giving us the condition that the limit as f of x approaches 2 exists, and f is continuous at x equals 2, and f can be differentiable. So let's picture a continuous function. For example, you have a continuous function. The limit does exist, but when you're talking about limits, where the limit as f approaches, as f of x as x approaches 2, when you're talking about when justifying a limit that exists, it kind of more like determining continuity. This statement helps you determine if the limit, if a given limit is continuous. And if you don't, if you guys know that, if you don't guys know that what is continuous, continuous means a function that keeps going. Like what I mean is, like, there is no open dots. All points exist. For example, if let's say this. I'm sorry about my graph. This will be called a removable discontinuity because there's no point over there. So that means that doesn't exist at that point. So that kind of goes back to continuous continuity, that all points exist. And based on that, we cannot use this problem because it kind of defines continuity. But option number two, f is continuous at x equals 2. Yes, that can conclude because as we say again that 2 exists, must exist. So that means that there should not be no open point at that coordinate of x value. So that means that it has to exist. So this one does follow the solution. F is differentiable. So it means that if I take the derivative of it, it will still have a number. Like, it doesn't change at all. It's gonna be differentiable because as long as it's continuous, differentiable will follow it. So according to sample choices, 2 and 3 will be the final answer. Okay, so sorry about the black screen, people. I am currently right now pulling another problem for you guys. It's a little complicated. Like, I understand, like, there's a lot of rules, and it's a lot. Uh, Believe it. Okay, so let me give me a moment to pull out a problem. Hmm. Okay. I hope you guys had a good day here, and we're ready to ace those AP tests. I know that these times are very rough, but we got this. No worries. I'll try to help you guys as best as I can with these AP problems. Give me a moment. Sorry for the latency. Um, okay, so we're ready to go. Okay, so let me go back to my screen. Okay, now I have another problem that still goes back to continuity, ladies and gentlemen. Okay, so the graph of the function f shown above has a vertical tangent at x equals 2. So it has a vertical tangent and a negative 2, sorry, and horizontal tangents at x equals negative 3 and at x equals negative 1. Which of the following statements is false? So keep in mind that we want an information that is false and irrelevant. So let's look at sample A. F is not differentiable at x equals negative 2 because the graph of f has a vertical tangent, and that is true. That is true because it does have a vertical tangent. So since this problem is true, we can cross that out because we want false information. F is not differentiable at x equals 0 and x equals 2.5 because f is not continuous at x equals 0 and x equals 2.5. Okay, so it does give a point that is not this is a removable discontinuity. So at x equals 0, it has a removable discontinuity, and at 2.5 has a removable discontinuity. I could just plug in a hole here and make it continuous, but I'm not very comfortable that it's differentiable because they're removable discontinuities. they can still be differentiable because I could just plug in a point there and make it differentiable as continuous. So this answer cannot be it. F is not differentiable 1.5 and 1.4 because the graph of F has sharp corners at x equals 1.5 and x equals 4. Okay, so a sharp corners is means this, and we can at 1.5 we can see that is true, but at x equals 4, 3 and 4 we does see it also. That is, if it was like true justifications, that is, but we're not looking for truth, so this is a false information. So final option, f is not differentiable at x equals 3 and x equals -1 because the graph of x has a horizontal tangent at x equals -3 and x equals -1. Okay, so let's see. So a horizontal tangent. So this statement is actually false because you do have this horizontal tangent, but at x equals -1, it just doesn't make sense because you're going all on the function of x. It will have to be more like a vertical tangent or something else, or it's just like at this point. At this point, this is continuous to this point. So I will say that D is going to be the final answer because it's false. And let me pull up one last problem for you guys, and before ending this video. Okay, to make it more interesting, we're gonna take some derivatives. So let me pop up back my screen. Okay, so let's say that they're telling us that let's say that f of x equals 3x to the fifth plus cosine x minus sine no, minus 7x to sorry to the fourth power, and they're asking us find the derivative. So in order to get the derivative, I will have to differentiable everything, d over dx, and then when I take the derivative of f prime of x equals, move the power to the front and subtract 1. That's how I learn easy by my teacher. Credit. And plus the derivative of cosine is actually sine of x minus 28x to the third. So that will be your answer for derivative for basic differentiation. It's pretty much easier in the concept, but let's go with a little tricky problem. So let me just ignore this for now. So let's say that they're asking us to find the derivative 1 over x to the 7. So x to the 7. I don't like that power being in the bottom, this x to the 7. So I'm gonna rewrite it first. That is gonna be x to the power of -7. No. I was wrong. Pardons. Yes. Okay. So forget what I said. You don't rewrite it. You use actually one of the rules. in determining the derivative. You use the quotient, the quotient rule. This rule helps to take derivatives of divided functions. So it says according to the quotient rule, it says that the derivative of the first minus the regular g times regular g, sorry, minus the regular f times the derivative of g divides over of g squared. So that means that that's a division. So we could picture, let's picture it out like this is f, this is g, and we just simply apply the quotient rule and we'll move on from there. So it's going to be f prime of x equals, so let's see, f, since 1 is a constant, that's a 0, times the regular g times x to the 7 minus 1 times the derivative of x to the 7, that's 7x to the 6 all over g squared, that is x to the 7 squared. So 0 and x, boom, cancels out. F prime of x equals negative 7x 6 all over, okay. If you guys are confused to, it's going to be x to the 7 times x to the 2. So that's going to be x to the 14 power. That's the and since I have x to the 14 power, I could just do this simple trick, canceling out x to the 6. X to the 6, that's going to subtract from the bottom one, so it's going to end up having f prime of x equals negative 7 over x to the 8 power. That will be your final answer, and that's pretty much it. Another method, if you don't want to use the quotient rule, you could just use the power rule. You could just use the power rule besides using the quotient rule. Using the power rule. So like instead, for example, I don't want to use the quotient rule because I'm out of time. For example, I will do this. Rewrite the function. Since I don't want the x to the 7 in the bottom because I don't want to do the quotient rule. So I'll move it in the front, and it will be x to the negative 7. So when I take the derivative of it, it's going to be equal to negative 7x to the power of negative 8. It's going to be negative 8, and that equals negative 7. And okay, so ladies and gentlemen, a common rule in differentiable. When you want an answer of something, for example, you should never have an x with a negative power in the top, because that's gonna make your question completely wrong. You gotta do it in the mathematical format to put in the right answer. So let's say, so negative 7. I don't. My answer will not make sense if it has a negative 8 as a power. So I will move it in the denominator, and it will change the sign to positive, because that's how math works. When you flip it over, when you move this x to negative 8 power to the bottom, it's a positive, as what we did on this problem. So that could be another way to determine a derivative. You could either use the quotient rule or apply the skills of a power rule. Keep note that you will have to rewrite it, the function. So it's pretty much basic. So okay, we're gonna still continue with more problems, ladies and gentlemen, and my goal is to teach you guys math. I really love math. I'm a student. I love this. I'd be happy to help others, really. So okay, let's go with another problem. Okay, so let's say that they're not giving you, they're giving out this problem, for example, 4, and they say that they want the derivative, like say like what, like what would you have to do? So first rule of it, you will have to rewrite it. So let's say that it's kind of like a square root. So x, this is a power 1, for example. So it's going to be power 1 over 4. And you just take the derivative. So taking the derivative will be 1 over 4, x to the negative minus 1 over 4. It's going to be 3 over 4. And that's pretty much it. Thank you for your cooperation, and I hope these problems will help you. Have a good rest of your evening, and take care all.